So far you've learned how to add, subtract, and multiply polynomial functions. This week we're going to focus on dividing polynomial functions. The first way we're going to learn how to divide is using long division, and our next method, which will be in your next task, will be synthetic division. Polynomial long division is very similar to numerical long division. We set it up the same way. What we would like to do is we take the number that we're dividing, so 675, and I put it here, and then the number I'm dividing by would go on the outside. And then we just ask ourselves, how many times does 21 go into 675? Well, let's break it apart. 21 doesn't go into 6, but 21 can go into 67, a total of 3 times. 3 times 21 is 63. We would like to subtract that number, so 67 minus 63 becomes a 4. And then remember, you would bring down your next term, which is 5. We need to ask ourselves, how many times does 21 go into 45? And the answer that is 2, because 2 times 21 would give me a 42. Subtract that number from the 45, I get 3. How many times does 21 go into 3? Well, it doesn't. 3 is too small. So 3 is what we would call our remainder. You would write your remainder as 3 over 21, which is equivalent to 32 and 1/7. Just some more terminology. The number that we are dividing is called our dividend. The number we are dividing by is called our divisor. And our answer would be our quotient. You may hear me use this terminology. Now, whenever we're dividing polynomials, like I said, it's a similar idea to numerical long division, and you'll see that as we work through these problems. The first step is always to make sure that everything's written in standard form, and sometimes you might need to put a placeholder, which is a 0. You'll see that in some of the examples that we go through today. Example 2, we have 6x squared plus 7x plus 2 divided by 2x plus 1. So 2x plus 1 is our divisor, 6x squared plus 7x plus 2 is our dividend. It was already in standard form, and it did not need any placeholders because I have an x squared, an x, and a constant. So it's the same idea where we have to ask ourselves, how many times does this go into this? We would start by asking, what do I have to multiply my first term by in the divisor to get the first term in the dividend? Okay, so 2x times what would give me 6x squared? Well, 2 times 3 would give me the 6. And x times x would give me the x squared. Now I need to subtract an expression. That expression will be given to me by 3x times the divisor. So 3x times 2x plus 1. We need to distribute in order to figure out what that would be. So 3 times 2 is 6, x times x is x squared. We wanted that because, look, now we're in a position to cancel it out. And then 3x times 1 is 3x, and it's a positive at that. When we are subtracting, remember, that subtraction sign goes to each of the terms. So if you'd like to, you can go through and change the signs. So this becomes plus a negative 6x squared and a negative 3x. Okay? So these cancel out, and I have 7x minus 3x, which gives me 4x. Just like numerical long division, we need to bring down that next term, which is a 2. And then remember, we ask ourselves, what do we have to multiply this by in order to get the first term here? Well, 2x times what gives me 4x? That would be a 2 and a positive 2. So positive 2 times 2x plus 1 is what I would want to be subtracting from that expression. If I multiply it out, I get 4x plus 2. Remember, we are subtracting this expression, so that negative goes to each term. So this becomes a negative 4x and a negative 2 that we would now add because I changed the signs. These cancel out, and then I have 2 minus 2, which becomes a 0. That's my remainder. Because 2x cannot go into 0. Whenever you have a 0 for a remainder, you don't have to write anything afterwards. This would be my quotient. And because 0 was the remainder, I made a note up here that it means that we have a factor. We found a factor to the equation. And we'll talk more about that when we see synthetic division. Example 3. We need to set up our division problem with standard form. So if you take a look at example 3, we see that this is not written in standard form. The 3x cubed should have come first. Next would be my squared term, and I have a positive 4x squared. Now I need to put my x term. There is no x term, so this is where we would need a placeholder. And then the number 10 would follow. Our divisor is x minus 2. So we ask ourselves, what do I have to multiply x by to get the 3x cubed? The answer to that would be a 3x squared. So we are going to be subtracting 3x squared times x minus 2. If we distribute, we'd get a 3x cubed minus a 6x squared. Remember, to distribute the negative, this becomes 3x squared minus 3x, oops, I meant to say cubed. 3x cubed minus 3x cubed. So these are gone, and then I have a 4x squared minus a negative 6x squared, so this becomes 4x plus 6x squared, so 10x squared. And then I need to bring down my 0x. Now I need to ask myself, x times what will give me a 10x squared, and the answer to that is a positive 10x. 10x times x minus 2 is the expression that I'm going to be subtracting. So 10x times x is 10x squared. 10x times a negative 2 is a negative 20x. 0 minus negative 20x becomes 0 plus 20x, or just 20x. And then we need to bring down that plus 10. What do we have to multiply 20 by, or excuse me, x by to get a 20x? The answer to that would be a 20. So I'm going to be subtracting 20 times x minus, and that becomes a 20x minus 40. Remember, we are subtracting this expression, so 20x minus 20x, that would cancel. 10 minus negative 40 becomes 10 plus 40, or 50. If you ask yourself, what do you multiply x by to get 50, you cannot. You would actually have to divide by x in order to get rid of it. So this would have to be my remainder. I stop here. And remember, whenever we have a remainder, we need to write it as a fraction. The remainder will go in the numerator, and then in the denominator, we would have our divisor. So it's plus 50 over x minus 2. Moving on to example 4, we need to check and make sure this is written in standard form, and it is. We also need to see if we need any placeholders, which would be if we're missing a term. I have x to the 4th, 3rd, 2nd, 1st, and then the number. So there are no placeholders here. I'm just going to rewrite it. My divisor is x plus 3. And we're going to start the process all over again. So what do I have to multiply x by to get x to the 4th? The answer would be x cubed. So I'm going to subtract whatever x cubed times x plus 3 is. If I distribute that, that would give me x to the 4th power plus 3x cubed. Because I'm subtracting, these cancel out, and the negative 3x cubed minus 3x cubed becomes a negative 6x cubed, bringing down my negative 4x squared. What do I have to multiply x by to get a negative 6x cubed? Well, the answer to that would be a negative 6x squared. So I multiply negative 6x squared by the divisor. That gives me a negative 6x cubed, and then a negative 18x squared. Because we're subtracting, these both become addition signs. So these cancel, and then 4 plus 18, or I meant to say a negative 4 plus 18 would give me a positive 14x squared. Bring down that negative x. I now need to ask myself, x times what will give me 14x squared? And the answer to that is a 14x. That is what I'm multiplying the divisor by. So that would become 14x squared. And then 14 times 3 would be 42. So I put plus 42x. These would cancel out. I have a negative x minus a 42, so that becomes a negative 43x. Bring down the 8. X times what would give me a negative 43x? The answer is a negative 43. So I have negative 43 times x plus 3. I'm going to be subtracting a negative 43x, and then negative 43 times 3 would give me negative 129. Okay, I'm subtracting this, so this cancels out, and then I end up with 8 minus a negative 129, which becomes 8 plus 129, giving me 137. So this would be my remainder. Remember, remainders should be written in the numerator of a fraction, and then the divisor would be in the denominator. So that's my final answer. If you're sitting in class right now, I would like you to try these 2 problems, and then let me know if you have any questions. If you're a remote learner, you're going to have to pause the video, attempt the try problems, and then hit play when you are ready to check your answers. Number 1 had a placeholder, so make sure you included that 0x. This is your final answer. The remainder was negative, so when I wrote it, I could have put plus a negative 23 over x plus 3, or you could have written your final answer as minus 23 over x plus 3. Either one of those would have been acceptable. Feel free to pause the video and compare your work. And then number 2, once again, feel free to pause the video and check your work. Otherwise, I'm just going to mention that it was not written in standard form for the dividend, so that's the first thing that I did. And then I ended up with a negative remainder. So once again, you could write it as plus negative 13 over 3x plus 1, or it becomes a subtraction, so minus 13 over 3x plus 1.